The scariest thing in science isn't an explosion, a black hole, or even the end of the universe. It's the moment when logic itself collapses, when two perfectly valid truths smash into each other and leave you with a paradox, something that should be impossible but stubbornly refuses to go away. And right now, in quantum physics, there's one paradox so disturbing that even seasoned scientists admit it keeps them awake at night. It doesn't involve aliens. It doesn't involve science fiction. It involves reality itself, the foundations of what we believe happens when something is observed. Because the terrifying question is, what if reality doesn't exist in the same way for you as it does for me? What if we could both look at the same experiment, measure it honestly, follow all the rules of physics, and end up with two different realities that cannot be reconciled? This is not a thought experiment dreamed up by a philosopher with too much coffee. This is a live, tested, peer-reviewed problem in modern quantum mechanics. It's called the Wigner's friend paradox, and it pushes science to its breaking point. It suggests that objective facts, the one thing we believed we could trust above all else, might not exist. Let that sink in. If facts themselves are negotiable at the quantum level, then every assumption about truth, evidence, even cause and effect starts to wobble. And the worst part? Recent experiments suggest this isn't just math games, it's real. So let's step into the paradox that terrifies physicists. Let's see why it could unravel the very idea of reality itself. To understand why Wigner's friend is so disturbing, we need to go back to one of the strangest aspects of quantum physics, the role of measurement. In classical physics, a rock is a rock whether you're looking at it or not, but in quantum mechanics, things don't work that way. A particle can exist in a superposition, many possible states at once, until it's observed. Observation forces it to collapse into one definite outcome. That's already weird enough. But here comes the twist. Imagine you set up a classic quantum experiment. A photon goes into a device that has a 50-50 chance of flipping its polarization. Your friend is inside a sealed lab performing the measurement. They look at the photon, record the result, and for them, the outcome is settled. The photon is no longer in a superposition. It's either one way or the other. But from your perspective, standing outside the lab, your friend and the photon together are part of a larger system. Until you open the door and check, you must treat both the photon and your friend as still being in a superposition. From your view, your friend has not yet seen a definite outcome. They're entangled with the photon in a cloud of possibilities. Here's the paradox. Inside the lab, your friend has a concrete fact. The photon is up or down. Outside the lab, you describe the entire lab as being in a state of uncertainty. Both descriptions are correct according to quantum theory, but they contradict each other. How can a measurement both have and not have a definite result? How can facts depend on who's looking? This is where Wigner's friend goes from quirky to terrifying. It suggests that reality might be observer-dependent, not just in terms of what you perceive, but in terms of what is actually true. If your friend writes, "the photon is up" in their notebook, and you treat that notebook as part of a superposition until you check it, are both of you living in different realities that only collapse when compared? Physicists tried to brush this off for decades as a philosophical oddity, but in recent years, experiments inspired by this setup have been performed, using entangled particles and sophisticated measurement tricks. And the results hint that Wigner's nightmare isn't just theoretical. It's possible that objective facts, shared across observers, don't always exist. If that's true, then the world as we know it, a world built on verifiable facts and shared reality, may be an illusion. But here's the real cliffhanger. If two realities can exist side by side, both valid, both consistent, then whose reality wins? Our common sense screams that reality has to be the same for everyone. If you and I look at a red apple, we may argue about its shade, but the apple itself doesn't vanish for one of us while staying solid for the other. Reality, we assume, is shared. But the Wigner's friend paradox doesn't just challenge this assumption, it demolishes it. Think about it. In the sealed lab, your friend has written in their notebook, "Photon is vertical." That's their fact. It's solid, ink on paper. But for you, standing outside, the notebook, the ink, the very neurons firing in your friend's brain are still in a state of quantum fuzziness. You can't treat their result as real until you interact with it. From your perspective, your friend's entire reality is suspended, not fake, not imaginary, but in limbo. This means reality is not a single shared canvas. It may be more like overlapping sheets of paper, each observer writing their own version, and only when they meet do the sheets snap together, sometimes agreeing, but not necessarily always. Here's where the illusion cracks. We've always believed that measurement is a one-time event that locks reality. The apple is red, the coin landed on heads, the photon is vertical. But quantum mechanics whispers something darker. The fact you believe you observed might only be true from your frame of reference. Someone else, equally valid, might live in a world where the opposite fact is true, and both can be correct. This isn't about perception or opinion. It's not like disagreeing on politics or taste. We're talking about factual contradictions being equally real. It's as if in one reality, the Titanic sank, while in another, it never left port. And both realities are scientifically consistent until observers are forced to compare notes. Even more unnerving, what happens when we do compare notes? Quantum mechanics suggests that only then is a global reality forced to emerge. Until then, we live in fractured pockets of truth. This breaks the sacred rule of science, reproducibility. If experiments don't produce universally agreed results, the very foundation of knowledge is shaken. And let's push it further. If facts themselves are observer-dependent, then history becomes a fragile construction. What we call the past might not even be the same for different observers. Reality may not be a single chain of events, but a tangled web of coexisting truths that only resolve when interaction forces them to merge. It's hard to overstate how disruptive this is. We humans survive on the assumption of a shared reality. Without it, communication, law, trust, even morality start to crumble. Because if my reality and yours don't line up, then what does it mean to say something is true? And just when you think this is only an abstract headache, quantum experiments are showing hints that it's more than a metaphor. If Wigner's friend were just a thought experiment, we could shrug it off as another weird riddle, like Schrödinger's cat. But what terrifies scientists is that the evidence is mounting. The paradox isn't staying inside the philosophy department. It's leaking into real experiments. Let's climb the ladder. Step 1. Superposition is real. For decades, people argued whether particles really exist in multiple states at once, or if superposition was just a mathematical trick. But experiments like the famous double-slit test, repeated with photons, electrons, even large molecules, show that particles do behave as if they're in many states until measured. This isn't speculation. It's the bedrock of quantum mechanics. Step 2. Entanglement spreads uncertainty. If two particles are entangled, measuring one instantly affects the other, no matter the distance. Einstein called it spooky action at a distance, but it's been demonstrated thousands of times. Entanglement means that uncertainty and superposition aren't confined to tiny particles. They can stretch across systems, binding outcomes together in strange, non-classical ways. If a particle can be entangled with another particle, why not with a whole observer in a lab? Step 3. Observer-dependent facts tested. In 2019, a team at Heriot-Watt University in Edinburgh built a quantum experiment directly inspired by Wigner's friend. Using entangled photons, they simulated two observers making measurements. Shockingly, the results suggested that different observers really could record contradictory facts that remain valid until compared. This wasn't theory anymore. It was experimental data saying reality might not be objective. Step 4. No-go theorems. Physicists have tried to find loopholes, ways to restore a shared objective reality. But the mathematics keep slamming the door. The no-go theorems in quantum foundations show that if quantum mechanics is correct, you can't assume facts are absolute for all observers. Either you abandon quantum mechanics, which works flawlessly in every test, or you accept the possibility that reality is fractured. Put these steps together, and the picture is chilling. Superposition is real. Entanglement spreads it. Experiments show facts can diverge. Theory blocks any escape route. The latter leads to one unsettling summit. Objective reality, the one thing we thought we could cling to, may not exist in the way we imagine. And now comes the question that truly rattles physicists. If there's no universal reality, then what happens when two conflicting realities collide? What emerges when truth itself is contested, not by humans but by the fabric of the universe? Philosophers have always wrestled with reality, but quantum mechanics has turned their abstract puzzles into urgent scientific dilemmas. Wigner's friend isn't just a curiosity. It forces us to ask whether truth itself is negotiable. And that shakes every foundation we stand on. If facts are observer-dependent, then objectivity, the holy grail of science, is in jeopardy. Science thrives on the idea that experiments can be repeated and verified by anyone, anywhere. But what if two honest observers get incompatible results? Which one is the real truth? The terrifying answer may be both. This echoes old philosophical debates. Idealists like Berkeley once argued that reality only exists when perceived. Materialists countered that the world exists independently of us. For centuries, materialism won. But Wigner's friend drags Berkeley's ghost back into the lab. If an unobserved system doesn't have definite properties, then the act of observing isn't just passive, it's creative. We don't just record facts, we bring them into being. Critics argue that maybe we're misinterpreting quantum mechanics. Perhaps hidden variables exist that restore objective reality. We just haven't found them. But Bell's theorem and decades of experiments crush that hope. Local hidden variables are ruled out. Others suggest the many worlds interpretation. When the friend sees up and you see superposition, both outcomes exist, but in different universes. That way, objectivity is preserved within each branch. But this solution is hardly comforting. It multiplies reality into an infinite foam, leaving us with countless fractured versions of ourselves. Another camp insists that consciousness plays a special role. According to this view, reality only collapses when a conscious mind observes it. But then we're stuck with a mystical universe where physics can't proceed without psychology. That leaves many scientists deeply uncomfortable. The philosophical shockwave goes further. If truth itself is relative to observers, then morality and meaning, which depend on shared facts, wobble. What does justice mean if what happened can differ for different observers? What does history mean if the past itself may be fractured? And here's a more personal sting. Your memories, your experiences, your facts might only be locally true. They could be valid in your frame, yet incompatible with someone else's equally valid frame. That makes reality less like a solid wall and more like a shifting mirror, one that reflects back differently depending on where you stand. This isn't just philosophical play. It forces us to confront the possibility that truth is not singular but plural. And if that's the case, then every foundation, science, history, law, even identity, begins to blur. But there's a darker frontier still. If reality itself is fractured, then what happens to the future we're building? Especially as quantum technologies begin to exploit this paradox. The Wigner's friend paradox might sound like a headache confined to dusty textbooks, but the future is rushing toward us, and this paradox could become terrifyingly practical. Why? Because the technologies we're building, from quantum computers to quantum networks, don't just obey quantum rules, they exploit them. Take quantum computing. These machines rely on superposition, allowing qubits to represent many states at once. They also depend on entanglement, linking qubits in powerful webs of correlation. But if facts themselves can diverge depending on observers, what does that mean for a quantum calculation? Could two users of the same machine, in principle, extract different, valid answers from the same process? If so, what happens to trust in data when even computation can fracture into conflicting truths? Then there's quantum communication. Scientists are already designing quantum internet protocols, where information is transmitted using entanglement. These systems promise unbreakable security, because any eavesdropper would disturb the fragile quantum states. But here's the eerie twist. If observers can record different facts, then what does secure communication even mean? Is it possible that Alice and Bob, two users on a quantum network, could end up with different realities of the same message, and both be correct? That would shatter the idea of universal consensus, the very thing our global infrastructure depends on. Beyond technology, there's the human side. Imagine courts trying to settle disputes when quantum evidence can support two incompatible realities. Imagine science itself, fractured into camps, each with experimental results that can't be reconciled with the others, not because of error, but because reality won't cooperate. The dream of a single, unified science could crumble into a landscape of local truths. Physicists fear this because it points to a profound limit. We may never have a full picture of reality, only observer-relative snapshots stitched together by fragile comparison. That means progress in science could hit a wall, not because we lack tools, but because nature itself refuses to yield a single truth. But perhaps the most haunting horizon lies in consciousness. If different observers truly live in different realities until they interact, then what happens when artificial intelligence begins to participate in quantum experiments? Will machines, with their own observer status, generate realities we can't access? Could we soon face not just fractured human realities, but machine-built worlds layered on top of ours, equally valid and equally unreachable? This isn't just a paradox. It's a crack in the very fabric of the future. If the universe allows multiple contradictory realities to coexist, then maybe the real question isn't whether we can find the truth, but whether truth itself was ever meant to exist. We've been talking about paradoxes, experiments, and theories, but let's make this personal. What does it actually mean for you that reality might not be objective? Think about your daily life. You believe in shared facts, that when you send a text, the other person receives the same words, that when you flip a light switch, the bulb turns on, that when you wake up, the world outside your window is the same one you left the night before. These small certainties hold your life together. But Wigner's friend whispers that certainty itself may only be local. What feels like a fact to you might not even exist for someone else until you meet and compare. That means your world is less like a stone pathway and more like a river, solid for you as you walk, but shifting and reconfiguring for every other observer. You're not moving through one universal reality. You're weaving through a tangle of overlapping realities, colliding with others only when interaction forces alignment. On a deeper level, this raises unsettling questions about memory and identity. Your memories are the record of your personal facts. But if facts are observer-dependent, then your memories are truths for you, not necessarily universal. What you call your life story may not match the life story of another person who shared the same events, and both of you might be right. Now flip this around. If truth is relative to observers, then meaning becomes something we build, not something handed down by an objective world. That can be terrifying, but it can also be liberating. If reality doesn't exist independently of observers, then your perspective isn't just opinion. It's literally part of what makes the world real. Your choices, your focus, your observations are not passive. They help carve out which version of reality unfolds. Seen this way, Wigner's friend paradox isn't just a cosmic horror story. It's also a strange empowerment. It suggests that each of us carries a fragment of creation in our perspective. Reality isn't a movie we watch, it's a story we co-author. And yet, the danger lingers. If each observer holds their own truth, what happens when those truths diverge too far? On the scale of individuals, it may be manageable, two people disagreeing on memory or perception. But on the scale of nations, technologies, or civilizations, fractured realities could become catastrophic. This is why the paradox terrifies scientists. It's not just physics, it's about us. Our lives, our trust, our very sense of belonging to the same world hangs in the balance. So where does this leave us? With a universe that seems to mock our deepest assumptions. We thought reality was the one solid thing we could count on. Yet Wigner's friend suggests that even facts, the bedrock of science, the thing we build our entire world upon, may be unstable. But before we sink into despair, let's step back. If reality is fractured, it doesn't mean chaos, it means complexity. It means the universe might be richer, more layered, more dynamic than our simple models could ever capture. It means that your perspective isn't trivial. It's part of the puzzle of existence itself. And maybe that's the deeper message hidden inside this paradox. That truth isn't a single stone tablet etched for eternity, but a living tapestry woven from countless observer threads. Each of us contributes a piece. Each of us shapes how reality crystallizes. In that sense, the paradox isn't just terrifying. It's intimate. It says, you matter. Your act of observing, of choosing, of being here, it changes the game. Of course, the haunting question remains. If realities can diverge, what happens when they can't be stitched back together? Will we find a deeper theory that restores a universal truth? Or must we accept that the universe was never one thing to begin with? As you think about that, picture this. Tomorrow morning, when you wake up, the sunlight filtering through your window is a fact only in your frame until you share it with someone else. Reality waits for you to notice it. So here's my challenge. Do you believe this quantum paradox changes everything? That truth itself may be an illusion? Or do you think science will eventually tame it, restoring one solid reality? Tell me below, because your answer isn't just opinion. In a strange way, it might be part of what makes the world real for all of us.